Hello, George Romanic here. Welcome to Fundamentals of Weather and Climate playlist. In today's video we are going to discuss the optimal angle of solar panels in order to acquire most of the solar energy. To do that we are going to consider an idealized horizontal surface in the northern hemisphere, but the same concept can be applied to the southern hemisphere. And we want to install solar panel over here. The first point of this video where we need to be technical is to of course know that our solar panel, which I will depict like so, should face south. So this should be south. That is because the sun is rising in the east and then traveling across the skies over the south, setting in the west. So the sun will have the highest position and therefore the highest intensity of solar radiation when it is over south. And to understand that better, please check my videos on the angle of the sun for different latitudes and times of the year, as well as my video on the seasons. Now, this angle of solar panel, it turns out is easier to optimize if we put normal over here and we try to optimize this angle, let's call it alpha. Now, you can say this is a stand that is holding solar panel. And we try to optimize this angle, keeping in mind that solar panel is normal, which we indicate like this on this stand. Why would we complicate our life and we try to optimize for this angle rather than perhaps angle of the solar panel with the horizontal? Actually, we want to simplify our life, and that's because if the sun is here over the south, then you can see that the sun rays will hit this solar panel like so. So now you can see that this stand is pretty much anti-parallel with these sun rays. Namely, they are parallel or anti-parallel, whatever you want to call it. We also therefore assume that these solar rays will hit this solar panel under the right angle of 90 degrees. So when we cleared that, the question is, for which day or days or seasons do we want to optimize this? Because the position of the sun in the sky changes from one season to another, from morning to the evening and so on. And in this video I will describe procedure, or rather the procedure is general, but I will apply this procedure to optimizing this angle for the winter season in the northern hemisphere. Namely, summer season already has very high intensity of solar radiation, so we will already harness a lot of solar energy, whereas the winter season, when the bills are highest for heating, is usually the season for which we want to optimize this, because we pay a lot of money for heating. If we want to extract electricity to use it to convert to heating energy, then we want to optimize for winter. And the second reason we want to optimize for winter is the intensity of solar radiation is weaker in winter than in summer, so we want to get as much of that energy as possible. Now, when I said we want to optimize this angle for the winter season, the question is, how do we do it? Do we pick a particular day during a winter season, or we try to optimize for average conditions during winter? The answer is we want to optimize for average conditions during winter. To do that, we will consider two particular dates. One is the first day of winter, 21st December, and the second is last day of winter, or rather first day of spring, which is 20 March. And of course, on 21st December, the sun will be lower in the sky at noon than on 20 March. So what we want to find is the angle of these solar rays, which is this alpha, on this date, and angle of these solar rays at noon on this date, and then find the average angle, which will be indicated with red like so. And we want to optimize our angle for this average ray angle during this winter season. So how do we find these angles? I will say the procedure without deriving it here, because this is fundamental playlist and I might derive it one day in my advanced playlist on Thursdays. The procedure is following. It has two steps. Step number one. find the number of latitude degrees between location where you want to install solar panel and the location where the sun is directly overhead. Step number 2, subtract that value from 90 degrees. The result is the angle of the sun above the horizon at the latitude where you want to install your solar panel. Let me demonstrate this because what I just said, I understand, can be confusing. I will demonstrate this for the latitude of Montreal, which is 45.5 degrees north. So latitude where I want to install solar panel is equal 45.5 degrees north. And now I want to find angle of the sun on 21st December at noon at this latitude. First is to find angle where the sun is directly overhead on that day, 21st December. Well, that's easy actually. Because 21st December is the first day of winter in the northern hemisphere, therefore it is also the first day of summer in the southern hemisphere. And we know that when we have first day of summer over the southern hemisphere, the sun is directly overhead over which latitude? Did you check my video on latitudes and seasons? Of course you did. That latitude is known as the Tropic of Capricorn. And that latitude where the sun is directly overhead on 21st December at noon is 23.5 degrees south. And again, please keep in mind, because this is southern latitude, it will have negative sign. Northern latitudes have positive sign, southern latitudes have negative sign. So now we need to subtract these two latitudes. But keep in mind that 45.5 degrees minus negative 23.5 will result actually in plus, because minus and minus give plus. So I will have this relationship. So what is the sum of these two? 5 and 5 is 10, 3 and 1 is 4, and 5 is 9, and 4 and 2 is 6. So 69 degrees. That was step number 1. Find the number of degrees between the latitude where you want to install solar panels and the latitude where the sun is directly overhead. Step number 1. Step number 2. Subtract this number from 90 degrees. 90.0 degrees minus 69.0 degrees. So that is 0.9 to 10 is 1. 6 and 1 is 7, up to 9 is 2. So the answer is 21 degrees. So this angle on 21st December that I just calculated, this angle is 21 degrees. That is the angle of the sun on 21st December at noon at 45.5 degrees. Now I want to repeat this calculation, but I want to repeat it for 20 March. So in step number 1, we will have the same latitude of the solar panel, 45.5 degrees, but what is the latitude where the sun is directly overhead on 20 March? Well, that's very simple from my video on the seasons. When we have first day of spring or first day of fall, then the sun is directly overhead. Where? Over the equator. Sun is directly overhead over the equator, which has latitude of 0. So if I subtract these two, I get 45.5 degrees. Now I subtract this number from 90 degrees. Five to 0 is 5. 5 and 1 is 6, up to 10 is 4. 4 and 1 is 5, up to 9 is 4. So the answer is 44.5 degrees. So this angle over here is 44.5 degrees. And now we want to find the angle of the red ray, which is the average of these two numbers. To find average, I sum them and divide by 2. So 44.5 plus 21, 44.5 plus 21.0, 0 and 5 is 5, 4 and 1 is 5, and 4 and 2 is 6. And now I want to divide this by 2 to get average. So this will end up being 6 divided by 2 is 3. And then 5 divided by 2 is 2. 2 times 2 is 4. Up to 5 is 1. I lower this 5. I put dot over here. And then this is 7. 7 times 2 is 14. And there will be more. But I will say clearly this is approximately 32.7 degrees is approximately 33 degrees. So this is my final answer. The angle of the red ray is 33 degrees. Therefore, the optimal angle alpha is 33 degrees. Now, if you really want to find this angle, let's call it beta, which would be the angle literally between the solar panel and the horizon, then that's very simple from here, as you can see. How is it simple? Well, it's simple if you know a little bit of geometry. And a little bit of geometry says this over here, notice, is right triangle. This is 90-degree angle. So, and the sum of all angles in a right triangle is 180 degrees. So that means 180 degrees is the sum of these three angles. Well, this is a right angle, that's 90 degrees, plus alpha is just what we calculated, 33 degrees, and plus this unknown beta. So let's do this. So 180 degrees is equal 90 and 33, let's do it. So that will be 123 degrees plus beta, which means that beta is equal 180 degrees minus 123 degrees. 3 to 0 is 7. 2 and 1 is 3. Up to 8 is 5. And 1 to 1 is 0. So it ends up that this angle is 57 degrees. So you can see if you want this angle beta, then this is how you get it. That was a little bit more advanced technique that gives you more precise optimal angle of these solar panels. Of course, if you want to optimize this for the summer season or spring season or any other set of dates, you follow the same procedure. There is another technique which is more simple and a little bit more crude, but it's very, very simple. It says if you want optimal angle in terms of this beta, then the optimal angle is the latitude degree where you want to install this solar panel plus 10 to 15 degrees. So let's see how that would match our more advanced calculation, where I said that this latitude where we want to install a solar panel is 45.5 degrees. And the rule of thumb says, well, take that latitude and add 10 to 15 degrees. So let's add, what do you want, 10 or 15? Let's add 10, it's easier. So you get 5, 6. And you can see that we are not far off. 45.5 plus 10, 55. See, I messed up something. 55.5. 45.5 and 10 is 55.5. Professor Romanic forgot how to sum up things. Anyways, notice that 55.5, using this simple rule of thumb, is very similar to 57. So if you don't want to go through all this hula hop, you can just use rule of thumb. The most advanced technique, which is used in industry sometimes, is to have a mechanism that will adjust this angle of solar panels for different positions of the sun throughout the year. But then the angle is variable and you need more sophisticated equipment to achieve something like that. Please make sure to like and subscribe, share this video with your friends and family, enemies, girlfriend, boyfriend. Please make sure to leave a comment, and until next video, goodbye.